In today's notes, we talked about how to write numbers from standard form to scientific notation. Standard form is the way that we write numbers on a regular basis. 15 is a number written in standard form. 1,200,000 is written in standard form. And we're going to take those numbers and we're going to write them in scientific notation. And scientific notation is written in the form of a number times 10 raised to an exponent. And we get the exponent by moving the current decimal place either left or right in order to get one number in front of the decimal. Now what that means is if you look at question number 4, there is a current decimal point already in place, and we need to move that decimal point so that there is one number in front of the decimal, and the number has to either be 1, 2, 3, 4, 5, 6, 7, 8, or 9. There cannot be a 0 and there cannot be 10. So you want to move the decimal point so that there's one substantial number in front of that new decimal point. If you look at number 1, there is no decimal point that's in the problem, so I added it to the back. Okay? Now if we look at number 1, there's my current decimal point in the back, and I need to move that decimal point so that there is one substantial number, one of those, in front of the decimal. So if I put the new decimal point just one loop to the left, there would be 4 numbers to the left. So I only want one number, and I want the substantial number. So notice here how I put it in between the 6 and the 4. If I put it in between the 6 and the 4, there's one number in front, and it would be the 6. And there's numbers to the back, which is totally fine. Now I'm going to take my pencil and I'm going to count the loops to see how many loops it took me to get from the original decimal point to my new one. And so here's my loops. I'm going to count 1 loop, 2 loop, 3 loops, 4 loops. Now 4 is going to be your exponent, and because I went left, my exponent is positive. So far in my formula I have times 10 to the positive 4th. Now this A piece in my formula is the decimal that was created. The decimal that was created was the 6.4. If there's zeros at the end of the number, you do not write them in your answer. Okay, and that would be your final answer. If you look at number 4, okay, I have a current decimal point as it is, but in order to have one of these numbers to the left of it, I'm going to have to move that decimal point all the way to the right so that the 1 is to the left of the new decimal. So I'm going to put my pencil where the original was given, and I'm going to count the loops. Now remember, in order to get to my new decimal point, I have to move to the right. Moving to the right makes my exponent negative. So I'm going to count my loops. For every number is 1 loop. So we got 1, 2, 3, 4, 5, 6, 7, 8. So that would be 9 loops. So this is going to be times 10. My exponent is going to be negative because I went to the right, and I counted 9 loops. The decimal that was created based on that number is 1.52. Notice how there's one number to the left, and you just copy the numbers as long as they're not zeros in the rest of your answer. Okay. And I'll look at one more. If you look at number 7, my current decimal point is at the end of the problem because there isn't one. And I need to move that decimal point so that there's one number in front of my decimal. So I'm going to move it so that it's right after the 5. Now, in order to go from my old decimal to my new decimal, I have to move to the left, which will make my exponent positive. And it goes 1, 2, 3, 4. So this is going to be times 10 to the 4th power. And my decimal piece that goes in front of my scientific notation is 5.264.